All right, in this video, we're going to calculate the present value of an ordinary annuity, and we're going to see an example just to clarify this concept. Before that, let's just revise the concept of annuity, right? So annuity is simply a series of level cash flows, like occurring at, or like equally spaced periods in the future. So we have three types of annuity: ordinary annuity. We've explained this in previous videos. This is just a refresher. And we have what's called annuity due, and we have a perpetuity. So ordinary annuity will have a series of cash flows occurring in the future, starting first payment starting at one period from now, at time is equals to 1. Annuity due, on the other hand, has the first payment occurring at time is equals to 0, which is today. And a perpetuity has the first payment, or the first cash flow, occurring at t is equals to 1, but the future payments will go on forever. Payments will go for perpetuity. That's the name perpetuity. So now we have this problem that we're going to solve, and let's just import that problem. And it's a retirement problem. So basically what happens is that you are retiring today. So you're retiring today, and you must choose to take your retirement benefits either a lump sum or as an annuity. So annuity is a series of cash flows occurring at certain period, and the opposite of that would be receiving that whole cash flow at the same. That payment as a lump sum. So the lump sum. So the this is a retirement problem. And the problem is deciding whether to take your retirement money as a lump sum versus as an annuity. Okay. And your company's benefits officer is presenting you with two options, right? Either a lump sum. Today we're going to give you a lump sum of $2 million, or we're going to give you this as a series of payments every year. Every year, with the first payment today, payment 1, 200,000 today, and after this, for the next 20 years, we're going to pay you $200,000 every year, compounded 7% per year, compounded annually. And so ignore tax. There's no other like tax considerations that you're going to make in this calculation, but basically the options are these two. So either we're going to give you, so you're retired, you're done with our company, thank you for your service, here's your retirement options. Today we're going to give you either, the first option is that we give you $2 million today and we'll give you nothing after this, or we're going to pay you 200,000 today, and every year, at the end of each year, we're going to pay you 200,000 for 20 years, compounded at 7% per year, with interest rate of 7% per year, compounded annually. So what's the problem? The problem is to calculate. So we know that this $2 million is worth $2 million today, right? Because we're gonna receive this today, right? At t is equal to 0. So the present value of this $2 million is $2 million, right? But we don't know. It's not very straightforward to know what the present value of this annuity would be, right? So our job, our job is to calculate or determine the present value of each option and choose whichever is greater. Which means, which one is greater? $2 million today, or the present value of the annuity, which we don't know. This we don't know. We have to calculate this and see if the present value of this series of payments for the next 20 years is greater or less than this $2 million. All right. So before that, let's talk a little bit about this R. So let me just change my, just to refresh our knowledge about interest rates and how we're going to use them in these kinds of calculations. So this R is described as 7% per year. It says compounded annually. See? So this part is the stated interest rate. And this part is the number of times our money is compounded. Whatever money we have in the account is compounded. The number of times per year it's compounded, right? So basically, since this is compounded annually, we can use this 7 directly into our formula. So our formula, which is the formula we use to calculate the present value, is given by the annuity amount 1 minus 1 over 1 plus r raised to n divided by r, where a is the annuity amount, n is the number of periods, and r is the interest rate. Now, if the interest rate is described as whatever per year compounded annually, then we can directly put the 7 or 0.07 directly in this. But what if in the problem that's posed, this was expressed as, instead of being expressed as 7% per year compounded annually, what if it was expressed as 7% per year compounded quarterly? Now we have to choose, we have to find the effective annual rate of this rate, right? We can't just put the 7 in this R and use it in our calculation because we're told that it's compounded quarterly. We have to change this into an annual interest rate. It's per year, but it's being compounded quarterly. But we have to change it into an interest rate where we can express it as compounded annually, just like this one. So this is where the formula for effective annual rate comes into the picture. So in previous videos, we've seen that the effective annual rate is calculated as 1 plus the periodic interest rate, right, to the power of m minus 1. Now, where RP is simply the periodic interest rate is simply the stated interest rate divided by the number of times of the number of times the money in the account is compounded per annum, right? So in this case, this part is the stated interest rate. This part is our M, which is 4 because it's quarterly, 4 times a year. So using this, we can calculate the effective annual rate for this rate as 1 plus RP is RS over M raised to M minus 1. This is simply 1 plus our RS is 0.07 compounded quarterly raised to 4 minus 1. This is simply 1 plus 0.0175 to the power of 4 minus 1. And if you do this, you'll get around 0.07186. And this is about 7.18%. So if the problem said, instead of said, oh, the interest rate is 7% per year compounded annually, instead of that, it said 7% per year compounded quarterly, we have to change this into an annual interest rate like this, and you see 7.18 in our formula here. But fortunately, it said compounded annually, so we can just directly use this 7% in our present value formula. So now let's just do a timeline and see what this is all about. So I always like to use a timeline so that it makes it easier to understand. So we have this timeline, right? Timeline. Today, year one, end of year one, end of year two, end of the 19 year, end of the 20 year. So your company benefits officer is saying either I'll give you $2 million today, or I'll give you your payment one today, 200K. And for the next 20 years, I'm gonna pay you 200K per year, 200K per year, 200K per year, 200K per year, compounded at 7% each year per year, 7%. So 7% per year. So now you're trying to determine, should I just take that $2 million today, or should I just opt for this annuity payment? I don't know. How do I do that? So we have to determine that present value of our annuity, right? With this formula, 1 minus 1 plus r raised to n over r. How do we do this? Very simple, right? So we have our annuity amount occurring at the end of each year. So let me just do plot here. So he's gonna pay us the first 200K at time is equal to 0. Okay, so annuity amount 200,000. 1 minus 1 over 1 plus our interest rate 7%, 0.07 raised to. Now the trick is, what's n? Is n 20 or 19 or some other number? So this year already. So let's think about this as an ordinary annuity. An ordinary annuity is where the first payment occurs at t is equal to 1. So for a while, let's forget the first year and start from here to here. So if we think about this as an ordinary annuity, because this payment is occurring at the beginning of the year, today, but for the next years, the payment is occurring at the end of each year. So this is going to mess up our calculation. So let's take it out and see it from the first year up to the 20 year. So how many years do we have? So we have, this is year one, and then year two. If this is year one, I mean, this is year two, right? Because this is year one. So we have, how many years do we have from here to here? We have 19 years, right? We have 19 years because we have not counted the first year. We have 19 years. So forget this and let's talk about this. We have 19 years. So our N is 19 here, right? And divided by 0.07. Now this will give us about 2,067,119 and 5 cents. Now we have the first $200,000 and we add first $200,000 from the payment that we got at the beginning of the year, and this will be about 2,267,119.05. So this is, what is this? This is the present value of the annuity option. Definitely the present value of the annuity, which is 2,267,119.05, and the lump sum which we received today is 2 million. See? Now, both are present values. This is, we're going to receive this today, and even though we're receiving the annuity over 20 years, the present value of all of that payment is this much. So obviously the annuity is greater than the lump sum today. So it's better for us as retirees faced with this option to go with the annuity, because the annuity is almost greater than the lump sum payment by almost $267,000. I mean, even we're receiving 2 million today as a retirement, we might just waste it. We $2 million on our hands. We might not know what we're gonna do with this. So we probably um, need the annuity payment. And even if we pass away at some point, we will have our other beneficiaries that can take the payment. So anyway, so the present value of the annuity is greater than the lump sum. So we will go with the annuity option.